A star has vanished from our galaxy, and the way it disappeared should be impossible. Stars do not simply fade into nothing. They live, they burn, they die, and when they reach the end of their life cycle, they let the universe know. They erupt in spectacular detonations or collapse in predictable ways, but astronomers recently found a star that ignored every rule, every equation, and every expectation. It didn't explode, didn't shed its outer layers, didn't leave behind shock waves or glowing remnants. It just dimmed until it practically wasn't there anymore, as if the universe erased it with one quiet gesture. The discovery sent a shock through the scientific community because nothing in our current models accounts for a disappearance like this. The star, catalogued as VVV.IWT.08, had once shone brightly in the crowded central region of the Milky Way, yet during routine monitoring, researchers saw its brightness collapse by over 97%. That kind of drop would normally suggest a catastrophic event, but there was no sign of destruction. The light didn't flare, the surrounding gas didn't react. Space around it remained eerily calm. To understand how strange this is, imagine watching a lighthouse at sea simply switch off, not flicker, not fade gradually, but shut down instantly without any explanation. That's exactly what happened here. For years, scientists rechecked the data, scanned the region, searched for debris fields, infrared signatures, or any trace of ongoing stellar activity. Nothing. The star behaved as though someone covered it with an object so enormous and opaque that nearly all its light vanished. Some astronomers suggested this could be an eclipse caused by a giant ringed companion or a colossal disk of dust orbiting some unseen body. But for the dimming to be so deep and last so long, the obscuring structure would need to be unbelievably vast, far larger than anything known in planetary or stellar systems. The odds of such a thing perfectly aligning with Earth's line of sight are astronomically low. This raised another possibility, one far more unsettling. What if the star didn't dim because something passed in front of it, but because it experienced a type of collapse scientists never anticipated? What if it skipped the explosion entirely and sank into darkness without releasing the energy that usually betrays a star's demise? If that happened once, could it be happening elsewhere?
The idea that a massive star could collapse silently has fascinated astronomers for decades, but until recently, it existed only as a theoretical scenario. In traditional models, when a star runs out of fuel and its core collapses, the energy produced blasts the outer layers outward, creating a supernova visible across galaxies. But some simulations suggested that, under the right conditions, a star might crumble directly into a black hole without producing the dramatic explosion we expect. If such failed supernovae occur, they would create exactly what we see with VVV-WIT-08, a sudden, unexplained loss of light with no visible debris. Yet this explanation introduces another complication. The star wasn't massive enough to undergo that type of collapse. It wasn't one of the giants expected to fall inward under its own gravity. This mismatch led researchers to reconsider what they knew about stellar evolution. Could there be a hidden threshold? Could medium-mass stars sometimes follow an alternative path we never predicted? Another idea gained traction. The star might still exist, but be obscured by a massive exotic structure. This structure could be a supersized ring system, something resembling Saturn's rings but scaled up so drastically that it spans distances comparable to planetary orbits. If such a ring belonged to a rogue brown dwarf or a dark companion star, and that companion happened to drift between Earth and VVV-WIT-08, it could produce the observed dimming. But this hypothesis requires a remarkable coincidence: perfect timing, perfect alignment, and an object of staggering size. And even then, the dimming curve of the star would normally show irregularities as the rings moved. Instead, the brightness drop of VVV-WIT-08 appeared strangely uniform, almost as if the obstructing body possessed an extremely sharp edge. Natural objects rarely have edges sharp enough to block a star so consistently. This led to bolder speculations. Could an unknown astrophysical structure, natural or otherwise, be responsible? Could the universe host massive, rigid formations made of dust, rock, ice, or some material we haven't yet discovered? Something large enough to cast a clean, deep shadow across light years of space. Most astronomers hesitate to jump to exotic conclusions, but the data pushes them into uncomfortable territory. If traditional models cannot explain the disappearance, the universe might be hinting at phenomena we've never imagined. And VVV-WIT-08 is not the only star behaving strangely.
As research continued, astronomers discovered a growing list of stars exhibiting similar behavior, objects that flicker, dim, or vanish in ways that defy established science. Some fade by 20%, others by 90%, and a few appear to blink in and out irregularly, like lanterns behind shifting cosmic curtains. These anomalies are most common near the Milky Way's densely populated center, where gravitational forces twist orbits, where dust clouds swirl violently, and where rogue planets and failed stars drift unnoticed. The environment itself might be shaping these mysteries. If giant dust disks, warped rings, or unclassified objects are abundant in that region, then the chances of witnessing extreme dimming events increase dramatically. But for the case of VVV-BTWIT-08, the scale is still extraordinary. The blocking structure would need to be dozens or even hundreds of times larger than the star. No known natural system produces structures that immense with clean geometric boundaries. Meanwhile, models attempting to replicate the dimming curve show that only an object with a broad, uniform, sharply defined leading edge could produce such a smooth drop in brightness. Dust clouds tend to create soft, uneven dips. Disks produce structured dimming with multiple shallow and deep points. But VVV-BT08 dimmed with a clarity that seems almost engineered. That does not imply artificial origin. It simply means that whatever caused it is unlike anything we routinely observe. Another possibility is that the star engulfed a planet or a small companion, triggering a temporary cloud of debris that shielded the light. But this scenario usually produces strong infrared signatures as the dust heats up. In this case, the infrared glow was minimal. Then came the most intriguing clue. When the region was reobserved later using deeper infrared imaging, astronomers detected a faint residual glow, too dim to match the original star, too bright to be empty space. It suggested that the object still exists but is drastically altered, obscured, or partially collapsed. If the star is still there but hidden behind something huge, then the obscuring structure might be part of a population of massive, unseen bodies drifting through the galaxy. If the star partially collapsed, then we may have witnessed a type of stellar death that challenges the entire foundation of how stars end their lives. And if neither explanation fits, then this mystery cuts deeper than anyone expected.
The next generation of telescopes may provide the answers. The upcoming Nancy Grace Roman Space Telescope will have the sensitivity and resolution to detect subtle changes in starlight, map faint dust structures, and identify rogue planetary systems that older instruments overlooked. If colossal ringed objects, dark companions, or gigantic dust walls exist, Roman will likely be the first to reveal them. It could expose an entire population of massive structures drifting across the galaxy, structures capable of blocking stars in ways we never predicted. But the implications of this mystery extend far beyond one star. If silent collapses occur more often than we thought, then the formation of black holes may be more common and more subtle than our models assume. Our galaxy could be filled with newly formed black holes that didn't announce themselves with explosions. And these objects may be influencing stellar motion, dust flows, and planetary orbits without drawing attention. This would fundamentally reshape our understanding of galactic evolution. On the other hand, if vanishing stars are the result of enormous orbiting disks or unseen ring systems, then planetary architectures across the Milky Way are far more diverse and extreme than scientists imagined. We might be on the verge of discovering systems where dust structures outsize entire solar systems, where dark objects roam with rings millions of kilometers wide, and where stars flicker behind cosmic formations unlike anything in our own neighborhood. So what actually happened to VVV WIT 08? The truth remains suspended between competing theories, each one extraordinary. Perhaps the star slipped quietly into gravitational collapse, becoming a dark remnant with no explosive farewell. Perhaps an enormous ringed body we have never seen before drifted into alignment and cast its shadow across space. Perhaps a hidden type of astrophysical structure, natural but unfamiliar, blocked its light. Or perhaps the universe is signaling that there are still categories of stellar behavior we haven't even begun to classify. Whatever the answer is, the disappearance of this star proves one thing with absolute certainty. The cosmos still holds secrets vast enough to rewrite our assumptions. Stars are not as predictable as we hoped. Space is not as empty as we believed. And somewhere out there, other stars may be slipping into darkness right now, quietly, invisibly, without a trace, reminding us that the universe is still full of wonders we have yet to understand.